Okay, so in this lesson we're going to be talking about properties of addition and properties of multiplication, and we're also going to be simplifying expressions. In this first chart I have properties of addition on the left, properties of multiplication on the right, but as you'll notice that they're kind of very similar, so when we talk about the commutative property of addition, I'll then talk about the same commutative property but of multiplication. So the commutative property of addition says let A and B be real numbers, so A and B can represent any number. Then we have, if A plus B, we also know that B plus A is the same. So if A plus B, that equals B plus A. For example, if you take 3 plus 7, which we know is 10, that's the same as taking 7 plus 3, which is also 10, right? The commutative property of multiplication is very similar. It says if A times B, then we also know that that equals the same thing as B times A. For example, let's say I have 3 times 4, which we know is 12. That's the same thing as 4 times 3, which is also 12. That commutative property says you're allowed to rearrange addition or multiplication, not subtraction or division, but addition and multiplication can be rearranged, which is really going to help us in simplifying later. Now, you've been doing this your whole life. You just didn't know it had a name, so here is the name for it, which is why you're allowed to rearrange it, is because of this property. The way I remember commutative, commute, do you see that word commute right here? Commute reminds me of like driving to work and then driving home at the end of the day, or for you guys maybe driving to school or riding the bus to school and then riding the bus home. Let's say 3 is your home and 7 is your work or school. Okay. If you commute, you're going from home to work every morning. And then at the end of the day, what do? You go from home back to, from work to home again, right? From work and school to home. That's how I remember this. Commutative property is like a commute. 3 plus 7, at the end of the day, you go back 7 plus 3. Okay, so you go to work and then you come home from work. Same distance, right? So going from home to work or from going from work to home, it's the same distance, which means these are the same. It's just that the order is different. For the associative property, let A, B, and C be real numbers. Then if we have 3 numbers always for associative, A plus B plus C. A plus B plus C with the parentheses around the A plus B. The associative property seems similar to the commutative property, but what the associative property does is lets you move the parentheses around for any addition problem. So I could first add B plus C, then add A. So for example, I could take 3 plus 4 plus 5, and that's going to be what? 7, and 7 plus 5 is 12, okay? Or I could reorder, not reorder it, I'm just changing what comes first. So let's say I add 4 plus 5 first, and that's 9, and 3 plus 9. Oh, look at that, it does work, okay? So if I rearrange the parentheses and choose which one I want to do first, that is associative property of addition. Notice that the 3, 4, and 5 stayed in the same order. 3, 4, 5, 3, 4, 5. It's just the parentheses which tell you to do which operation to do first. Okay. So the associative property of multiplication, again, the A, the B, and the C are all still in the same order, except on the first one I'm multiplying A times B first, and then the second one I'm multiplying B times C. For example, if I add 2 times 3 times 4, and I put parentheses around the 2 and 3, that's 6. 6 times 4 is 24. The associative property says I could take 3 times 4 first and get 12, and then 2 times 12. Look at that, it still is 24. This is what the associative property tells me. Our next property is called the identity property. We have the additive identity and the multiplicative identity. The identity, if you think about the word identity, you think of like maybe a mirror or something. You look in the mirror and you see yourself, or you're talking about yourself, right? So let's say we start with any real number A, any number A, and I add 0 to it. What should you get back? Itself. The identity. Remember, you start with A, you end with A. It's is identical. By adding 0, you're not really changing anything. You're keeping it identical, which is why we call it the additive identity. We can also reverse that and say 0 plus A is still A. So an example would be like 7 plus 0 is 7, which I know you've known this for a long time. This is just us giving a name to it. Next, multiplicative identity. Again, you start with A, and we want to end with A, so what do? Multiply by 1. A times 1 is still itself A, or 1 times A is still itself A. For example, 5 times 1 is 5. Notice that the additive identity is adding 0 to keep it the same. The multiplicative identity is multiplying by 1 to keep it the same. Our last property is the distributive property of multiplication over addition. Now I put this kind of underneath both categories. It's both addition and multiplication because you have a multiply here because whenever an A or any number or letter is next to a parentheses, that means multiply. But inside the parentheses you have an addition. So that's why it's a distributive property of multiplication over addition. So when you are identifying these properties in the future, if you just put distributive, I know it's the distributive property of multiplication over division, whereas the other ones you have to be a little bit more specific. So the distributive property says I can take A times each of the terms on the inside. So A times B is AB, plus A times C is AC. Now even if you have the A in the back, it still works. So that's still AB plus AC. And this is the distributive property. An example would be if I had 5 times x plus 2. If I distributed the 5 times x would get me 5x. 5 times 2 is 10. Okay, so that's the distributive property. So now what I want you to do is name that property. The first property, I have multiplication and division, and addition. So that tells me that this is going to be a distributive property. The 4 is being distributed to the x and the 3. This is the only one I don't really necessarily have to write addition or multiplication because it's actually of both the distributive property of multiplication over addition, and that's the only one there is. The next one, I start with 5 and I end with 5 and I'm adding 0. So adding 0 doesn't really do anything. It's identical. So this is an identity. So I'm going to write identity. And which one is it? Well, because I'm adding 0, this is the additive identity. All right, the next one. Let's see. I've got 9 plus x. And then x plus 9. That's going backwards order, isn't it? Going from work to school, back from school to work, right? You're commuting from one place to the next. So that is a commutative property. Is it a commutative property of addition or a commutative property of multiplication? Well, because the sign is addition there, I can say it's the commutative property of addition. Okay, next one. 3x plus parentheses 5x plus 10 equals 3x plus 5x plus 10. Notice that the 3x, the 5x, and the 10 are all in the same order, right? The only thing that's changing is the parentheses. That is an associative property. A lot of times people think, oh, if it's got parentheses, it's the associative property. That isn't necessarily always true, but the associative property always has parentheses, but just because it has parentheses doesn't mean it's associative. But in this case it is. Everything's in the same order, we're just changing what we're adding first. Again, we're adding, so it's the associative property of addition. Now this next one has a parentheses in it, but that doesn't mean it's associative. Again, there's only 2 things here, so it can't be associative. Associative has to have at least 3 things. Now we're multiplying x times 5, and then we're taking 5 back and multiplying by x. That's going forwards and backwards. That's commutative, like you're commuting to work. But in this case, it's commutative of multiplication because 5 times x and x times 5 is multiplication. All right, how about the next one? We've got an x equals 1x. This is super important. Anytime you have a variable x and you might need a coefficient, you need to understand that there's an invisible 1 there. But the property that says you're allowed to do that is the identity property. X, if you multiply it by 1, you still get x. So this is an identity property. It is actually an identity property of multiplication, and we actually write that with the multiplication in the front. It doesn't really matter if you have it in the backwards order, but it's proper way to do it is to write multiplicative first, identity property. Alright, our last one, 2 times 7x, or 2 times 7 times x. So notice the 2 and the 7 and the x are all in the same order. There's 3 things and the parentheses are moving around, so that's an associative property. But this time it's an associative property of multiplication because we're multiplying 2 times 7 and x. So those are all your properties.